Here we're going to demonstrate the operation of a small motor-operated valve, or MOV. The motor-operated valve is right here. We have an electric motor with a gearbox assembly that's able to rotate a ball valve. If you look down here, you can see the ball assembly itself. It's in the shut position. I can go open. You can watch it slowly rotate. So we have a full through ball valve, as you can see. I can go fully closed, and the electric motor winds it closed. We happen to be using a small PLC at this moment in time to drive outputs, to drive the valve open and close. We have some solid state relays here that are controlling the 120 volt power to the motor. And the schematic for this is actually kind of hard to see in this video, but there's a schematic here with showing a split winding motor. We can energize one wire or another to make it go different directions. Pretty simple setup. I wanted to show this because motor operated valves are very popular in certain industry applications, although you may find much larger valves than this. This is a fairly small valve, the Series 75 Worcester valve, but you will find applications of these in industry as well. I want to point out some of the basic operational features. For example, you've seen the motor already, how it can turn, and the gearbox, which slows down the rotation to make a very slow motion on the ball valve. I want to point your attention now towards these limit switches. These limit switches right here are mechanically actuated by the motion of the valve shaft through these cams. Those cast aluminum cams will rotate with the shaft and will push the leaf lever on the limit switch, causing it to trip. So watch closely. I'll move the valve here. You can see one limit just cleared, and these other limits are about to pick up. When I go back the other direction, those limits clear, and this limit picks up. Those limit switches tell the valve when to stop moving. If it weren't for that, the valve would just keep on rotating and rotating, going open and close, being a ball valve style. So I want to demonstrate very quickly how these limit switches work. I'm going to go back to the open position here. So here I go, and I'm going to force it to stop. You can see I've forced the valve to stop by triggering the limit switch. And so you can see that when the cam comes around, it will do that automatically on its own, and that is what forces the valve to stop moving. Likewise, if I go in the closed direction, it's a different limit switch that controls the closure. So that switch right there tells the valve to stop moving. And of course, if I let the cam do its job, it stops of its own accord. You can loosen off set screws here and move those cams back and forth to control how far open or how far closed you want the valve to go. This is a simple full bore ball valve, and so we're looking for 90-degree rotation, so you'll find these cams offset by 90 degrees. However, if you wanted to limit how far the valve opens, let's say not go all the way open, or for some reason not go all the way closed, you can change the positioning of those cams and force it to do whatever you wish. Now with larger MOVs, you're not going to find cam arrangements that are quite this crude. You'll find much more sophisticated styles of limit switches, but they all work on basically the same principle. The limit switch somehow monitors mechanically the position of the valve and then will open or close a contact to stop that valve's motion before it gets too far. They also have MOVs with electronic style limit switches that are not strictly mechanical, but they might use counters, like encoders, to look at the valve position very precisely. You also have some MOVs that actually have a potentiometer or an LVDT or some other sensor that's able to give an analog reading of that valve's position. And using that kind of mechanism with the appropriate servo circuitry, you can get the valve to proportion. So you could send it a 4 to 20 milliamp signal, for example, and have it proportion itself according to that analog signal. Here in this case, it's strictly an open-close valve, which is what you often find in pipeline and tank farm type of applications. Again, many valves in industry are larger than this, but this gives you an example of the basic concepts and shows you how the cam-operated switches are used to set the open and closing limits of the valve.